Here we have an order that asks for an infusion of 400 mils over 6 hours. The first question, question A, asks us about the delivery using a pump. So we need the flow rate, which is going to be the fluid running over time, and remembering that a pump, this fluid must be measured in mils and the time in hours. So we have exactly the right units. All we have to do is write that as 400 mils over fraction line 6 hours. There's absolutely no need to change any units, and we always just need to remember that the fraction line, the over, is actually dividing that volume in milliliters by the time in hours. So if we do that division, we get 66.6666 and recurrent like that. So we need to do some rounding here. Because it's mils per hour, one answer we could give would be rounding this to 1 decimal place. So the decimal point is straight after the 66, and if we wanted to round to 1 decimal place, the breaking line would be after the 6, after the decimal point. So the only one that would decide on this would be the next digit, which is 6 higher than 5, so we round up. So the answer would be either 66.6 or 66.7, but because that orange 6 there is higher than 5, greater than 5, we round up. So we would say mils per hour if we can enter that decimal point into the pump. So otherwise we would also probably just round it to the nearest whole number, so the 66.666 and so on. If we decided not, just the whole number should be what we enter in the pump, so we would then do the breaking line right at the decimal point, and we would drop everybody like we did drop these guys here on the top. Here the only one that matters for the rounding is the next one straight after the breaking line. It's a 6, same thing, it will round up. So the answer would be 66 or 67. There is no other possibility. Stays the same, 66 if we had a number, a blue number less than 5, or goes up like in this case, so it will be 67 mils per hour. Really important to write the units because this is a flow rate, and the rate always needs to be given with the units of watt per watt. Then in question B, we have to calculate again the flow rate, but this time using a 20 drop per mil set. Even if this had not been expressed here, if we knew or had been told this is a 20 drop set, we need to know that that is the 20 drop per 1 mil set. So how do we do this? Probably easier if we just do exactly the same thing, and I would suggest not to use the answer that we got in the first part of the question, because that is already rounded. We want as accurate as possible an answer. So I suggest when we're doing part B of a question, we go back to the original heading. So what do we have here? We have 400 mils to run over 6 hours using a 20 drop per mil set. So basically we are now not thinking about the pump anymore. As soon as we hear drops, we must remember the final answer will be, the rate will be in drops per minute. So what does that tells us to do? We need to change those 6 hours to minutes. So how do we change 6 hours into minutes? Each hour has 60 minutes, so just multiply by 60. So our time, delivery time, will be 6 6s are 36, 360 minutes. So I can even now ignore that 6 hours because my focus is in minutes. And how do we set it up? Similarly to the original one, the volume we want to run over the time, but of course in minutes because we are using a drop set. And of course we needed to somewhere use the drop set number here. So that will be times the 20 drops per mil. You see, I'm putting all units in because I just would like you to have a check and see why the final answer comes out in drops per minute. So what will happen here? Just like cancelling or simplifying fractions, the mil on the top with the mil on the bottom disappear. So look at what's going to be left in terms of units. Drops on the top per minutes on the bottom. So there is no mistake, our answer must be in drops per minute. You can write in words the per, or you can even write drops per minute like that, or even in full, drops per minute. So let's do the calculation. 400, well, you could do some, perhaps some cancelling as well. You could cancel a 0 on the top, a 0 on the bottom. So we have 40 divided by 36. Do some estimation. It will be around 1 point something, and 1 point something times 20 will give us 20 or 20 and a little bit. So this is just an estimation. So as soon as you push the buttons, you are expecting that size of answer, 20 something, not 200, not 2000, not 0.2. So if we do use the calculator, we find 400 divided by 360 multiplied by 20, we find 22.2222. Of course, this cannot be an answer, because if we're talking about drops, each drop has to be a whole drop. There's no half a drop, third of a drop. Just think about it. So we have to round this to the nearest whole drop, which is breaking line right at the decimal point. The one that is going to decide if this stays as 22 or goes up to 23 is that blue 2, the first one after the breaking line. It's too low, it's not going to round this up, so it will stay the same. Final answer, 22 drops per minute, or DPMs, or drops per minute. Of course, we would not use this decimal answer, because drops, like other things that you can think of, we don't use decimal numbers to express those elements.